G'day, I'm Yuki-san Dev, and in part 33 of the series Unity for the Absolute Beginner, we will work on enhancing our second game. Alrighty, so we are continuing on from phase 8, where we finished setting up the menu scene with the scoreboard. The basic game idea is pretty much done now. At this point, there are endless things you could do with the game. So in the next few videos, I'm just going to add a few things to give you some ideas. So let's get into it. Okay, so I'm opening the project up from where we left off in phase 8. So as I mentioned earlier, there is a ton of stuff you could now do to enhance this game. As far as making the game longer and with other kinds of levels, well, you could expand on this one. And in some cases, you might even have to plan it out first and then redesign the entire thing. Hence the importance of planning before jumping in. We haven't done that with this game because we're still in the beginner stages, and this was just to practice things that we've covered so far in the series. So a good challenge now would be to take a look at the code and try to figure out better or shorter or even ways that might be less intensive on the CPU. There's a lot of room in this code for changes, and as you learn more, you will see just where those areas are. Also think about using inheritance in this game and maybe have a look at protection. This game has many unprotected areas, and I will probably make a video on all these things at some stage, but in the meantime just have a think about it and see what you could do to change it. Alright, that's enough of this blurb, so let's get into it. So we have a wave display that tells you what wave we are playing, and we also have a display for how many lives are left. So let's do the same thing, but this time with a graphical representation to make it a little more fun. Since we already did the scoreboard, which might have been a little bit of a nightmare for some because of all the list references and nested classes, but this will be much easier, I promise. So the first thing to do is get the two images that we'll be using for this. Of course, you can replace them with something else later if you like. These two images are available in my GitHub link in the description. So drag the two images, the Creeper and MC Steve, into your images folder. Alright, and we're going to use these images in the canvas, so we need to convert them into sprites. So click the Creeper image, and in the inspector, change the texture type to Sprite 2D and UI, and click Apply. And now do the same for MC Steve. Alright, so they're ready to go, so let's get started on the canvas. So open up your gameplay scene if you haven't already and open the canvas. Now this canvas in here is a little messy from the previous videos, so I'm going to put a few things into empties here to tidy up. So create an empty for game over stuff. And another one for stats. And then I'm going to drag all my statistical stuff into the stats. And all the game over related stuff into game over stuff. There, that's better. Alright, now let's create a new empty and call it DynamicDisplays. And under that one, let's create two more. We'll name one Waves. And make another empty and name it Lives. Right, and now right-click Waves and select UI and Image. And I'm going to name mine Creeper. And click on the source image and select the creeper that we brought in earlier. You might have to search for it. Change its color to some kind of green. I'm going to use the one I always use, which is 00FF22. And size it down to 30 on both the width and the height. And finally, click on the waves empty and move it up to the top right somewhere next to the score. And remember, we're moving the waves object, not the creeper object. Alright, now let's do the lives. So right click on lives and select UI and image again. And I'm going to call mine MC Steve. And change its image to MC Steve. And let's size this guy down to 40 for height and width. And now move the lives container down to the bottom left somewhere. Alright, that's the canvas done. Now let's get some scripting done. So create a new C# script and name it DynamicDisplays. And drag it on top of the DynamicDisplays object in the canvas. And let's open the script. Alrighty, so this script will handle both the graphical wave and lives displays. So just like the scoreboard, we need to reference the containers, or as I always call them, bins. And we need to reference the actual graphic inside the bins. So let's do private transform waves bin. And then private transform waves graphic. And now the lives with private transform lives bin, and then private transform lives graphic. Okay, and now in start we will retrieve these with waves bin equals transform dot find waves, and the waves graphic equals waves bin dot find creeper. That's what we called it. And then we will hide our template graphic with waves graphic dot game object dot set active false. And now we'll do the same with the lives. So lives bin equals transform dot find lives, and lives graphic equals lives bin dot find MC Steve. And then we'll hide that one too with lives graphic dot game object dot set active false. So for the waves, we are retrieving the transform of the object called waves. Then we are retrieving the actual creeper image UI object. We don't need to specify the dynamic displays object because that's where the script resides. Then after we've retrieved the image, we hide it. And then lives is just the same, only the references are different. Okay, we're finished with start, so we can collapse that up to keep things tidy. And let's also remove the update method. Okay, so now we'll just create functions in here that the rest of the game can call on to update the graphical displays. So let's do the waves first. So we'll make a new public function that will have a couple of parameters with public void wave graphic, and then we're going to need the wave number, so int wave number, and we're going to need to know if it's a boss or not, so bool boss. We'll use the wave number so we know how many little creeper faces to instantiate in, and we're going to use the bool boss value so we know if it's a boss battle, because we want to change the color of the image for a boss battle. So now in between the curlies, let's make a spacing variable with float template width equals 35. And now let's put a condition in for the boss with if boss, and in between the curlies do waves graphic dot get component image dot color equals red. Now, depending on your editor, you may get a red line under the image component statement. If you do, then in the top of your using declarations, put in using Unity Engine .ui, and that should take care of that. Alright, and now outside of the boss's curlies, we will carry on by instantiating a new creeper clone image with transform the image equals instantiate waves graphic, comma waves bin. And then let's grab its rect transform with rect transform equals the image get component rect transform. And then we're going to position it in the scene with transform dot anchored position equals new vector2 template width times wave number, comma 0. And then finally we will unhide it with the image dot game object dot set active true. Okie doke. So we're saying firstly to change the image's color to red if it's a boss battle. Then we instantiate in the clone of the creeper underneath waves bin. Then we retrieve the instantiated object's rect transform so that we can manipulate it. Then we set its position in the scene by using the template width times the wave number on the x-axis. If you wanted to go down the screen rather than across, you would just change it with the y-axis. Then finally, we are unhiding the new cloned image. So now each time a new wave starts, we will call this function and it will create a new instance of the creeper next to the others. Alright, who's going to call this function? Well, it would have to be the spawner since it's controlling the waves. So let's save this script and let's open up the spawner script. Alrighty, well, we'll need to be able to talk to the new dynamic display script. So in our declarations, let's do private dynamic displays wave graphic. And now in start, let's retrieve it in a slightly different way for a change. So you see how we reference the game manager script here. Well, here's another way you could do it. Wave graphic equals find object of type dynamic displays. All these ways of retrieving things have their advantages and disadvantages and performance costs, etc. I'll leave you to work on that one. Right, so we have access to that function now. So actually when the spawner first starts up, it's going to start spawning immediately. So let's call the function right away and start with waveGraphic.waveGraphic, wave number, comma, false. So we're calling the function we made and sending the wave number, which will be 1. And we're telling the function that it's not a boss fight, so the graphic will stay green. Alright, now down in our coroutine, we need to call the function when a new wave starts. I'm going to slot it in right after the enemies are wiped with waveGraphic.waveGraphic, wave number, comma, false. And now each time this calls the function, the wave number up here would have increased. And the last place to drop this would be in the boss spawn function here. So again, after the enemies are wiped, we will do waveGraphic.waveGraphic, wave number, true. So this time the boss battle will be true. So it will come up red. And that's about it. So let's save this and give it a test. And click on the Game Manager object and set your player score to higher than the last wave requirements so that we can just skip through the waves. And jump back into the menu scene. And run. And there we go. Skipping through the waves, and each time a new wave comes, we get a new creeper face. And the boss is red. Cool. Alright, now let's get into the lives display. So back into the dynamic display script. Okay, so we're going to need 2 functions for this one. One function will be to display all the lives, and the other one to delete a life each time one is lost. So we'll get the default lives set up first. So let's create a new function, public void set lives graphic, and then the parameter int lives left. So this function will need to know what the lives left amount is, so it will be accepting an integer number for that and storing it in a temporary local variable named lives left. And now in between the curlies, let's do while lives left is greater than 0. And in between those curlies, let's use another float to control the spacing between entries with float template width equals 50. And now for each clone, we want to give the object a unique tag so that we can identify and delete the one entry when the life is lost. So these tags will have to be preset in the editor after we're done here. So let's do lives graphic dot tag equals life in speech marks plus lives left. Then we're pretty much doing what we did in the waves function. So we instantiate the clone with transform the image equals instantiate lives graphic, comma lives bin. And then we get its rect transform with rect transform equals the image dot get component rect transform. And we'll position it in the scene with transform.anchoredPosition equals new vector2 template width times lives left, comma 0. And we'll unhide this one too with the image.gameObject.setActive true. And then finally we minus lives left by 1 with lives left minus minus. So this loop will keep cycling while lives left is greater than 0. Okay, this function is done. And now let's do the update function for when the life is lost. Don't worry though, it's just one line. So public void update lives graphic int lives left. And then in the curlies, destroy gameObject.find gameObject with tag and life and speech marks again plus lives left. And we're done. So each time a life is lost, another script can call this function and send the new amount of lives left, which will be 1 less each time. And the integer amount will be used to identify which object to destroy by the tag with the same name. The reason we put the word life in front of the number is because it's never good in any game to name anything with a number by itself. So let's save this. Alright, and now regardless whether you're in the menu scene or the gameplay scene, just click on any object in the hierarchy. I'm going to click on the background here, and in the inspector go to add a tag. So in here we just want to add a bunch of tags that can be used in our script. In our case they are the word life followed by a number. So you can put any amount in here, just make sure you have enough for the lives that the player starts with. My player is going to have 3 lives. The starting life plus 3 extras, but just to be safe I'm going to put 5 in, so I'm going to do life 1 and life 2 all the way through to 5. Alright, now all we have to do is call these functions from the right places. Well, the game manager is the one holding the player lives variables, so from there we will call the set lives graphic. So let's open up the game manager script. Alrighty, and just like our spawner script, this one needs to access the dynamic displays. So private dynamic displays, and this time we'll call it lives graphic because that's what we're using it for. Alright, and in start we'll retrieve it with lives graphic equals find object of type dynamic displays. And now we can run the function in that script with lives graphic dot set lives graphic player lives. And of course we are sending player lives to it from here. Sweet. Now all that's left is to call the update script when the player gets hit. So let's get down to our player got hit function. Okay, and in our code, when the game is not over, we're just going to slot a line in. I'm going to put mine after the enemies are wiped. So lives graphic dot update lives graphic player lives. And finally, we want to grab the 2 lines before the if in our function and move them down to after lives graphic is updated. Alright, and we're done. This should all work. Let's save this. Now, there is one potential problem here, and that is that when the gameplay scene loads, it will run both the game manager script and the dynamic display script at the same time. The dynamic display script fetches references to canvas objects. The problem is that there is every chance that the game manager in start will call the function in dynamic displays to set the lives graphic up before it's had a chance to reference the game objects. So sometimes, if not always, you could get null object errors. To ensure this doesn't happen, we want the dynamic display script to run first. So jump back into that script and change start method to awake method. And save. Alrighty, we're ready to give this a crack. So I'm going to click on Game Manager in my gameplay scene. and put my player score back to 0 and set my player lives to 3 and make sure I'm back in the menu and run. Alright, and now get hit by something, and there it goes. Spare lives left down to 2. Cool. Now, just one other thing to note, if you want these displays for the wave and lives positioned somewhere else in the scene, just drag the container they're in around, not the image itself. The UI image's position is relative to the container, so the container is what you need to be moving. And then they will work in exactly the same way, just in a different position. Okay, well, I think that's it for this one. You could get quite creative with these ones, so have a crack at them. In the next video, I think I might do something like a power-up, maybe a shield or something like that. So I hope to see you in the next video.